But, whenever you're pushing the envelope, scientifically or technically, it's going to be harder than you think it is. So I think the length of time we have for development is one of the key lessons that we've learned. And our intent as we go forward is to make sure that we aren't compressing the different phases of design and development when we're actually trying to do something new and challenging.
Yes, right back here.
Hi, Robert Perlman with CollectSpace.com. Sort of working off of Irene's question earlier about communication management, how will Curiosity's arrival on the planet affect Opportunity's mission? Will priority be given to Curiosity in terms of communicating with Earth?
I don't necessarily think that's an issue. We have the two orbiters. We are able to track both orbiters at once with multiple aperture per multiple spacecraft reactor capability for DSN. So right now I don't see a tremendous conflict in terms of our data needs and Opportunity's data needs as we go forward. Certainly hope that Opportunity is there, so we have that opportunity to share the link with that.
Okay, hi, Mike Wall from Space.com. So you guys are going to be gathering a ton of data, and there's going to be a real bottleneck in terms of sending it home. Can you just kind of talk about what that's going to mean for folks who are not necessarily scientists but are interested in what you guys are discovering, like the views and the videos? How fast are you going to be able to get that stuff down? And I mean, how much are we kind of going to be able to see of these vistas that Curiosity is seeing?
I think John may correct me, but I think our current data rate is around 250 megabytes per day that we should get down. So that allows quite a rich amount of data. I don't in my caution before, I certainly didn't want to indicate that we're going to get 1/10 or 1/100th of the pictures down. I don't think that's the case. But certainly we're not going to get 100% of the pictures down. And we will pick and choose because the scientists will want very much to get the right context pictures to do the rest of the science investigation that they need to do.
Let me just add to that a little bit. The principal investigator, Mike Malin, when he designed the cameras, each camera has its own buffer, which is 8 gigs. And the science plan this time around is going to be a little bit different than what happened with MER. On MER, the science team would look at the NavCam images and then, based on those, select some subset of images to then shoot with the PanCam. This time around, what the PI would like to do is shoot a broader vista right away and return thumbnails. All thumbnails will come back. Then the science team will actually look at those color thumbnails and from that be able to select what subset you would actually downlink. So the buffers exist as a data management process to allow much bigger data sets to be acquired with the full intention that some subset of it will never be returned probably.
Scott Powers from the Orlando Sentinel. Pete, are there any upcoming significant milestones or challenges between now and August for this flight, or is it just going to be an ice cruise for 8.5 months?
Yes, we've got an engineering checkout that will occur in a few weeks and a science instrument checkout that will occur sometime thereafter. We have, of course, 6 trajectory correction maneuvers to engage in. The first one will be about 15 days out from today. The second one approximately 2 months out, and the third one about a month or so before we get to Mars, and the last 3 are for fine-tuning the entry, descent, and landing corridor. We are also planning 2 software loads, one in May to be the final update of the software for EDL and in the last phase of the mission, and one in June for a surface mission. So those are the key kind of major events that will be engaged on the spacecraft. On the ground, we'll be engaging in operational readiness tests, and we have about 10 planned between now and August. So we're going to be clipping off at more than one a month, 3 of them for entry, descent, and landing, and 7 of them for the surface operations.
To clarify, you said there are 3 trajectory changes between now and when it reaches Mars?
Right. There's a major aim bias that takes place when you go to Mars because the second stage, the Centaur, is also going to Mars. And it's not treated from a planetary protection standpoint the same way the spacecraft is treated. So the aim point right now is quite a bit away from Mars. And so the first trajectory correction maneuver will be to correct the aim point for what we want the entry point to be. All the trajectory correction maneuvers after that are basically to take out the errors of that first trajectory correction maneuver.
Okay, Ken?
Hi, Ken Kramer for Spaceflight Magazine. Question for John. You said the other day and today also this is not a life detection mission. I wonder if you could describe a little bit what kind of instruments you'd like to have to make it a life detection mission in the future. And a question for Pete. When you do get to Mars, you're going to be monitoring the weather so you can make last-minute changes in the entry, descent, and landing profile at all? And other atmospheric data, too. Thanks.
You're up first.
All right. So what I would want is lots and lots and lots and lots and lots and lots of rovers, because what we learn on Earth is that you need lots of humans to go out in the field and rocks that are 3.5 billion years old to actually find something that you can look at and hold up and hold a press conference like this and say, I found evidence of life on the early Earth. And again, I'll emphasize this throughout the mission. The great paradox here is that water, the very thing that enables life, when you convert loose sediment that might have microorganisms in it, and you convert that to solid rock, that requires circulation of many, many pore volumes of water, and water is an oxidant. So the water actually oxidizes the organics. And on Earth, the exploration for fossils that might be present in ancient rocks is quite serendipitous. You have to sort of learn how to get to a good spot that looks promising in terms of kind of cementing the material in very early on. If it happens later on, that's no good. You want to get it early on because most microorganisms degrade within hours or days. So you got to get them locked in early. And with that paradigm, then you begin to just poke around, and it's just really just collecting many different kinds of rocks. So I would imagine that what we could do as far as exploring ancient Mars is concerned is you do need to explore probably a couple of different of these landing sites and learn to become familiar with the patterns by which water converted materials, including potential organics, into rocks. So, and then in addition to that, you would need very specialized microscopes that you could use to take rocks on Earth. We cut them so thin you can pass light through them, and then you can see actually cellular structure and distinguish that from abiotic processes. The other option is to find what you think really is sort of the glory hole and get a piece of it and return it back to Earth. So, I think that latter option is the direction that the Mars program is headed in.
Okay.
The current instruments on MRO and Odyssey and Mars Express will in fact look at the atmosphere and give us data on any changes in the atmosphere that we might see. We don't expect this to have a dust storm because this is not dust storm season, but there could be inflation in the atmosphere as a result of other processes. Our entry, descent, and landing simulations and testing has taken a look at extremely broad atmospheric distributions in terms of pressure and density profiles. So I don't expect any surprises there, but we will, of course, fine-tune the entry, descent, and landing timeline based upon what we see.
Gene McCulka with Talking Space. Question for John. We got a good idea of what the engineering side is doing on the cruise out. What is the science side going to be doing on the cruise out?
Right. So Pete mentioned operational readiness tests, and we have several of those planned for the science team. And what we do is we work with Curiosity's twin, which is back at JPL on the test bed there. And it has a high degree of fidelity compared to what the spacecraft is. It's on its way to Mars. And with that, then, we undergo tests where the team actually thinks about what kind of sequences they would like to acquire on the surface of Mars, as it were. They get implemented, they get built, they get radiated to Mars, the data gets returned back to Earth, and in the simulation then the science team gets to practice with, for example, how you would do triage between the amount of data that's available, the amount of power that's available, the amount of time that's available. Basically the three fundamental resources that allow us to do the science experiments. And so then, we hope then with the 10 instruments to be able to learn how to efficiently do trade-offs and work with the flight software and interact with the engineers that will be required to help us do everything. And lots of training there. Yeah.
I'm Roland Keller of Swiss Engineering. after this beautiful flight, I would like to know what do you think about the international cooperation after the program ExoMars?
I think I have to answer that one. You know, we've been working with the European Space Agency for several years now, and you know, we are continuing to do that. We met last night to continue discussions. It's a very important partnership for us, NASA, with both the 16 mission and the 2018 mission. We continue to pursue those, and my 2012 budget that was just passed by Congress recently supports that activity, and we will continue pressing that. As you know, we have excellent international participation on MSL. I hope I get them all. Canada, Russia, France, Germany are all aboard. And Spain, thank you. And Spain are all aboard. I knew I'd miss one. It's been a long day. And so, you know, we work with the international community all the time. And this is expanding that with ExoMars, and we intend to continue to pursue that. So we want that to happen.
Todd?
Todd Halverson of Florida Today. I was wondering if you could tell us what you anticipate to get out of the descent camera, what we will actually see as a product of that instrument, and when we might see it.
So the descent camera turns on just moments before separation of the heat shield, and it acquires all the way to the surface at about 5 frames per second, full color HD resolution. And then after we touch down, it shuts off nominally. That camera is available to use throughout the mission on a best efforts basis after that. So that data set will be a very large one, and given the fact that we will want other critical engineering data to come down and also some other initial science products to come down, our guess is that probably initially within a week or two, there will be a subset of the frames that will be a pretty nice-looking movie that will be available, and probably within a few months it will be required to downlink all of the frames that would give you the complete sequence, something like that.
Any further questions? Yes, we have one over here.
Thank you. Jackie Goddard for the Sunday Telegraph of London. Already our launch coverage online is generating the usual array of reader comments that question the amount of spending on a mission like this, and why aren't we feeding the world starving and frivolous and waste of money. Do you find that kind of attitude demoralizing, and how do you redress that lack of understanding of the importance of this science that you're doing?
Yeah, I think any one of us could take that, but Pete and I have often discussed this, especially in the context of the 2-year slip. You ask in retrospect, you know, what does it mean that we've done that? I think you look back, and at least for this country, you take every child, woman, and man, and you divide the total price tag by the number of people, and it comes out to about the cost of a movie. So, you know, I'll leave you to judge for yourself whether or not that's a movie you'd like to see. I know that's one I would. I think the cost is a bargain for education for all the science team members that represent other countries as well. This is the stuff that fuels kids' imaginations to go into science and engineering. I can't think of anything better. I have a lot of friends of mine whose kids were watching early this morning at JPL, and it's about as good as it gets, and I think that's a great investment.
I'd like to add the standard cliche to that, however, which is we don't spend any money on Mars, right? We spend it all here. These are high-tech, good-paying jobs across the country that are created when you do something like this. I've not actually counted it up, and I know that there are thousands of individuals across the country, anywhere from high school educations to PhDs, that are gainfully employed, exciting other people, as you said, to bring more kids into the engineering and sciences. And frankly, that's what moves society forward. Very important.
All right. If there are no other questions, we're going to conclude, but as we go out, we're going to show some video of the spacecraft separation today, which everyone agrees was quite mind-blowing. So we're going to go ahead and we'll show that, and then that will conclude this briefing. Thank you very much.